Today we are going to solve radical equation. That first blank, an equation that contains at least one radical term with a variable in the radicand. For example, radical 2x minus 3 equals 5. Notice you have an equation, there's a radical there, and your variable is underneath the radical. When that's the case, it is called a radical equation. These are the steps. You're going to get the radical on one side of the equal sign, everything else on the other. If the radical is a square root, you're going to square each side. If it's not a square root, say it's the third root instead, you'll put it to the third power. If it's the fourth root, you'll put it to the fourth power. Solve the equation, and then you do have to check, because sometimes you get answers that don't work. So for our first problem, radical a equals 5. First thing I'm going to do is the radicals on one side, so I can skip the first step. It is a square root, so I am going to square both sides. When you square the left-hand side, you just get a. When you square a radical, you just get the piece under the radical. 5 squared is 25. Now for my check, what you do is you plug 25 into the original problem. So radical 25 equals 5. The square root of 25 is 5. Checks out. So a equals 25 is our answer there. Okay, that was an easy one. Next problem. We gotta get the radical by itself, so let's subtract the 3. So you have negative radical 2x plus 5 equals negative 3. Let's divide by negative 1. So that way it's just a positive radical. Now that the radical is by itself, we can square both sides. And then when I square the radical, I end up getting just 2x plus 5. 3 squared is 9. Solve for x, let's subtract that 5, so you get 4. Divide by 2, you get x equals 2. For our check, let's plug a 2 into the problem. So it's going to be 3 minus radical. 2 times 2 is 4, plus 5 is 9, has to equal 0. Square root of 9 is 3. 0 equals 0, so it checks out. Okay, moving on. The next one, I know the steps do say get radicals on one side of the equation. However, in this case, when you have a radical equaling a radical, what you'll end up doing is just start by squaring both sides. Radical 5x plus 2 is just 5x plus 2. Radical 9x minus 14 squared is 9x minus 14. Solving for x, let's get x's on one side, numbers on the other. So I'm going to subtract the 5x. I'm going to add the 14. So I get 16 equals 4x. Divide by 4, x equals 4. Now I'm going to check to make sure it works. So for our check, 4 times 5 is 20, plus 2 is radical 22, has to equal 9 times 4 is 36, minus 14 is radical 22. So it does check out. Alright, moving on to a couple more difficult problems here. For this next one, the radical is by itself, so we'll start by squaring both sides. When I square the b minus 3, that is a FOIL problem. You do need to remember that it's really b minus 3 times b minus 3. When I FOIL that, I get b squared minus 3b for the outside and the inside will end up being negative 6b. Negative 3 times negative 3 is positive 9. Equals, when you square the radical, you just get the piece under the radical, 3b minus 11. To solve something with a squared in it, what you need to do is you combine like terms, or you set it equal to 0 and combine like terms. So I'm going to subtract the 3b and add the 11. When you do that, you get b squared minus 9b plus 20 equals 0. Let's factor that. Factors of 20 are 20 and 1, 10 and 2, 5 and 4. The only ones that are going to add or subtract to a 9 are 5 and 4. So this will factor to b minus 5, b minus 4 equals 0. To solve, we set them both equal to 0 and solve for b. So adding the 5, b equals 5. Adding the 4, b equals 4. We do need to check that they both work. Just to save time and space, I am going to tell you that they do both work. So b equals 5, b equals 4 are our final answers there. Trust me, sometimes these problems do not work though, so it's always important that you check to make sure they do. Because if they don't, you need to cross them out. Next piece, notice it's a cubed root. To get rid of cubed root, what I said in the beginning was to cube. We have to cube both sides here. 4 minus, or the cubed root of 4 minus 2a cubed is just 4 minus 2a. Negative 2 cubed is 8. If you type it in your calculator, just type very carefully. Sorry, it's negative 8. When we solve for a, let's subtract the 4. So negative 2a equals negative 12. Divide by negative 2, and a equals 6. If I were to check it, and again, I'm just trying to save time, it does work out. But again, when you do your problems, you do need to check them for me. I just noticed as I was recording this that it may not be showing right on your screen for the last problem there. So I'm going to leave it up like this for a second so you can at least copy the work down before, even if you couldn't see it before, hopefully you can see it now. I will skip the last problem because something is going on with the recording today where I can't finish it. So at this point you can start working on the do now problems, and we'll see if we can figure this out for the next lesson.